So the diagram below, not drawn to scale, shows a circle with center O. So we have to keep in mind I have a center. This line, the line DCE, is a tangent to the circle. Let's check it out. So we have D to C to E. Okay, so it's indeed a straight line. Is a tangent to the circle, and yes, it is. Point of tangency. Angle AC is 48 degrees. Angle from point A to C to point E is 48 degrees. So we have a turn there. So looking from point A, going on to C, and we're turning at C to E. And that angle here is 48 degrees. The angle there is between a tangent and a chord. And angle OCB is 26 degrees. Angle O, this is angle O here. That's sorry, it's point O. And this point C. I'm going to turn to B. Get the angle of 26 degrees. Okay, so let's look at this question now. Seems pretty easy. And so what we have there is we have to identify what we've seen so far, and that will help us a lot. Okay, so what we're seeing a radius, and a radius meets a tangent. And we know that rule, that a radius meets a tangent. So we know this angle right in between here should be 90 degrees. All right, so we know that this is a radius. From the center of a circle to the circumference is a radius. And this is a tangent, and a radius meets a tangent at 90 degrees. So this should be 90 degrees there. So we can put a little right angle there. And obviously on this side is also a right angle because we have a radius, and then a tangent. So we know this is also over here, should also be 90 degrees. So the angle between this radius and this tangent is 90 degrees, and the radius and this tangent is 90 degrees over there. Okay, so now we found that out. So we know this angle, we can find this angle between here easily, as well as this angle between here. Okay, so this should be 90 degrees in total. So this piece should be the difference between 90 and 48. This piece in between here, because all the way down should be 90 degrees. What other things should we note as well too? All right, so we know this is the chord that divide the circle in a major segment and divide it in also a minor segment. Okay, and since this angle between this angle between chord 48, between the chord and the tangent here, this angle of 48 degrees is in the minor segment, of the chord AC. So the angle in the alternate segment, the major segment that is over at B, should be the equal actually. Angle in the minor segment between the tangent and the chord is equal to the angle over there in the major segment at the circumference. That's the alternate segment theorem. What else do we see in this that we actually know? Well, what we're seeing here is the angle at the center. Angle at the center is twice the angle at the circumference. So we say angle at O, whatever angle that's going to be, should be twice the angle at the circumference at B. And since if we figure out what B is, we double it to find the angle at O, since angle at O is twice it. Okay, so let's go on to start solving the problem. So that's a little review as to what we know so far, we studied so far. So here's what angle ABC, going from angle A to B to C. So I guess they want us to find this one first. Angle at the circumference. Okay, now how are we going to find that? Well, it should be noted that the angle at the circumference there can be found by looking at what we looked at early on. The angle between the tangent should come back to your mind. Between the tangent and the chord ABC is 48. So the angle that points over there, the angle in the minor segment, is equal to the angle over there in the major segment. So this is going to be 48 degrees as well. Okay, so that's 48 degrees. And the reason for that is alternate segment theorem. Alternate segment theorem. Okay, so that's 48 degrees. Angle AOC. So angle A to O to C. So this angle here. And now we notice that angle B has both legs standing on AC, and angle O at the center has both legs standing on the same AC. So angle at the center, therefore, is twice angle at circumference. This angle should be 96. Okay? It should be twice angle ABC, in other words. So it should be 96 degrees. What's the reason? Angle at center is twice angle at circumference. Forgive me on my writing. And the instrument is kind of slippery. Okay, so angle AOC is twice the angle ABC. Angle at center, twice angle circumference. BCD, angle BCD. So we're going to find this angle here, angle BCD, right between here. B to C to D. This angle right there. We already established that this angle from the radius right down to the tangent is 90 degrees. Because the angle in between, the total angle between a radius and a tangent is 90 degrees. So if we have part of it, which is 26, the next part of it should be complementary to 26 to up to 90 degrees. So that actually is 90 degrees minus 26 degrees. And so that should give us a 30 from 90, that's 60. And add on 4, that's 64 degrees. Yeah. And so that's going to give us, yes, 64 degrees. And the reason for that is radius meets tangent. Radius is perpendicular to tangent. Same thing as saying radius meets tangent at 90 degrees. They're perpendicular, in other words. Okay? They're perpendicular to each other. Okay, so now we found that. So this is actually 64 degrees. Next one, angle BAC. Angle BAC. So we look for this angle right here. From point B to point A to point C. So looking for this. So we move from B to A, or drive it on to C. So looking at this complete angle here. What is that going to be equal to? Okay, so that might be the only challenging one they can think of. Well, so far we know this entire angle should be, well, it's not really challenging. In fact, it should be actually easy. The angle between the tangent and the chord. If you look it over here, so angle tangent DCE, I'm looking at chord, we're looking over here, chord, right, chord BC, okay, angle between it is 64 degrees, and we're noticing that chord BC is pointing towards angle A, right? If you look at it, points at angle A. So this segment over here, so chord BC cuts the circle into two segments, the minor segment, and the angle in the minor segment is 64, and the angle in the major segment over here at B should also be 64 degrees. So angle BAC is equal to 64 degrees. And this is alternate segment theorem as well. Okay. Now we're down to angle OAC. Angle OAC. angle OAC. Now to find angle OAC is a little easy as well too. So let's look at it. I'm going to draw a circle down here. Okay, I think I need to do that a little better. Better job at that. Okay. So what we had there, okay, everything just disappeared. Okay, so let's go over this again quickly. This was angle. This was 48 degrees. We said this angle over here is 48 degrees. This one here is going to be 96 degrees. 48 degrees because this angle between the tangent and the chord is 48, and so the angle in the alternate segment to this minus segment 48 degrees, which is in 48 degrees. The angle in the minus segment here is 48, 48, and so this angle over here is in the major segment, so it's 48 degrees. So we call this the alternate segment theorem. And this one is angle at the center is twice the angle at the circumference, so it's 96 degrees. Okay, so this one is 48. We already put a reason early on, and this one is going to be 96 degrees. And this one, BCD, B to C to D, this angle right here. Well, this entire angle is 90 degrees, angle between a radius and a tangent. So you have to state it. We have to give our reasons. So this is going to be 90 degrees minus 26 degrees, and that angle should be 64 degrees. Angle BAC. Let's move from B to A to C. Now this angle, so this angle here is 64. The whole thing is 90. 64 plus 26 is 90. Now BAC, this angle right here, is what? Well, if you look at it, this angle here in this segment, because this is chord BC. So we're looking at this segment here in the minor segment is 64 degrees. And so the angle that this chord subtends at the circumference is equal to the angle between the same chord and the tangent in the minor segment of 64 degrees. So the angle that this chord subtending in the major segment is the same as this one in the minor segment. So this is 64 degrees. This angle right here. So angle BAC is 64 degrees. And of course, put the reason. Alternate segment theorem. So this one is alternate segment theorem. Alternate segment theorem. And this one was also alternate segment theorem. Okay. This one here was angle at center. Angle at center. Twice angle at circumference. And this was what? Radius. Radius meets tangent at 90 degrees. They're perpendicular. And OAC from O to A to C. So what I'm saying, we're going to draw a circle. Okay, and we have a center of the circle. What we call this line a radius. We also call this a radius. Now these two lines have the same length. So when we draw a straight line going across like that, what is formed is an isosceles triangle. Okay, I think I need to do that a little better somewhere down here. Okay, so what is formed there is this side and this side here. They're equal because this is a radius and a radius. All radii in a circle are equal. So what is formed there is an isosceles triangle. An isosceles triangle of this length is the same. That means the base angles will also be the same. Okay, so what we have in this circle here is that the angle at the center here is 96 degrees. So let's look at it. So let's draw this bigger. 96 degrees. And so, and we know that this length, same as this length, because this is a radius, and this is a radius. So they are the same length. So this angle here must be the same. And so how can we find that? How could we find that? Well, if that's the case, a second, let's tie this up a little bit. I'm sure you already start working it out already, which is really good. Okay, that give you some time to finish working it out. And so if we have an isosceles triangle with one angle being 96 degrees, what are the other two angles, which are the base angles? If the base angles, this angle here is equal to this angle here, and we know all three angles must add up to 180 degrees, then the base angles must be equal to what? So let's write that out. So we have 180 degrees, and we subtracted 96 degrees. This 96 degrees is not the base angle. It's just the other angle, the bigger angle. We'll take it away from that, and that will leave us with 4 and 10 to this 17, 174 degrees. Yeah. So, okay, this is awful. No, what am I doing here? So 6 from that, take away 7 here, and 6 from that, give us 10, give us 4, and then we have 9 from 7, 9 from 17. Let's give us. So I've made my mistake right here. Okay, 9 from 7 give us 8, so that's 84. So these two angles must add up to 84 degrees. Because this is 96. Okay, that's 96 degrees. To get 84, okay, to get 180, we have to add 84 to 96. Okay, and that will give us our 180 degrees. So these two angles must add up to 96 degrees. So I'm sorry, my bad, 84 degrees. So what we're going to do, we're going to take the 84 and divide it in two parts, and that will give us 42 degrees. So this angle here is 42 degrees, and this angle here is also 42 degrees. So angle OAC is equal to 42 degrees. Now this is a real long way of doing it, because we could have done that easier by just simply looking at this side. This is a radius, and this is a radius. This is a tangent. So the angle between the radius, I'm moving from the radius to the tangent, that's 90 degrees. And so if this is 48 so far, the next piece must add on to give us 90. So we're going to find OCA first. OCA. Angle OCA, which is equal to angle OAC, because these are base angles of an isosceles triangle. Base angles of isosceles triangle. Right? And they're equal. So once I find OCA, and OCA, angle OCA is equal to 90 degrees minus 48 degrees. And 50 from 90, that's 40 plus 2, that's 42. And therefore, angle OAC is equal to 42 degrees. Okay, so we could have done that the other way around as well too. We don't even have to trouble the fact that this is an isosceles triangle. Well, I mean, we don't have to actually go in this route, taking 96 and divide it by 2. But once we find one, we can find the other one. But we have to consider that, yes, that it is an isosceles triangle, because this is 42, then we can say yes, the other angle is also 42. Okay, the last one is OAB, angle OAB. Okay, now that should be simple. Angle O to A to B. Since we found angle OAC to be 42 and the entire angle BAC to be 64, then these two pieces must add up together to give you 64. In other words, if this entire angle here is 64 and this piece is 42, then what is this piece here that they're asking us for? Angle OAB. So we can find angle OAB quite quickly by putting 64 degrees minus 42 degrees, and that will be equal to what? Okay, so that's be equal to 2 from 4 give us 2, and 4 from 6 give us 2, 22 degrees. Okay, and that's about it. Okay, all right. Thank you for watching. This was a long video and I'm tired, but hopefully it was helpful. Okay, so hope you enjoyed. Take it down on examples. And please send us your feedback by emailing us at lennonmaths.com.